Hello everyone, today we're going to be talking about enzymes EC classification. It's a way that they classify enzymes. There are 7 groups. In some books they put 6, in other groups they put 7. I'm going to discuss the 7 in case you have to learn all 7 of them. Before I begin this video, I just wanted to say some of you guys are saving or liking, which is amazing, but also please follow because it takes time to create this content. I'm going to post a full video on YouTube and only part of it here on TikTok. So let's begin. So number 1 is E1 oxidoreductase. So it's going to be, like it says, it's an oxidation reduction type of catalysis. So for the example that I gave this molecule, and if you look, I'm going to be highlighting. You have here a carboxylic acid and another carboxylic acid, and you have your hydrogens, and here you have your hydroxyl. So I just want you to look specifically at this hydroxyl. So all the other groups remain the same, but if you look, it's like although it doesn't have like an extra oxygen, like an extra OH, it's double bonded to this oxygen. So it acts like it has 2 oxygens, even though in reality only has 1 oxygen, because double bonds are stronger than single bonds. So it was oxidized. And then if you look at NAD, it was reduced because it gained a hydrogen. So that's what you need to know. Since it added a hydrogen, it was reduced. Okay, so E2 is transferase. It transfers a functional group. So usually what you'll see, I didn't put out like a full reaction or but I just wanted you to see that the basic idea is, for example, adding a phosphate group. Like if you see in gluconeogenesis and glycolysis, you will see like ATPs becoming ADPs and that phosphate being added to that group. Like in the case of glucose, it becomes glucose 6-phosphate. So that would be a transferase. Hydrolase. Hydrolase is the next one, and that's a hydrolysis of bonds. So any type of protease that uses water to break bonds, that's a hydrolase. Then you have lyase. So I have to come in with those mnemonics, y'all. And if you stay till the very end, I have a mnemonic to remember all these groups together. So keep watching. So lyase is a non-hydrolytic, non-oxidative breaking of bonds. It's like, okay, that's so many words. What do you mean by that? So just think of it as like you have like an X. I mean, it's not exactly, but think of it like you have an XY and it becomes an X plus a Y. And it breaks into 2 groups. So that would be a lyase when it breaks into different things. So just think lies break people apart. In this case, it would be molecules. Number 5, you have isomerase. So for isomerase, it's literally isomers. And if you don't know what isomers are, I have a video on that. You can go check it out. But pretty much you're just changing the order of things. So I gave the example of glucose 6-phosphate becoming fructose 6-phosphate through the enzyme of phosphoglucose isomerase. Remember, we're talking about different enzymes here, so this is would be the E5. Then for E6, you have ligase. So I'm laughing because it will make sense for Spanish speaking people. So like ligar, and so to get together, it would be a good way to remember this. But I'm trying to think of a mnemonic for English speaking people, and just think of it like it's G will stand for glue, like they glue and stick together because they make a covalent bond. Okay, let's go to number 7. So we have translocase. Translocase, it just helps the molecule move across the cell membrane. So A on one side versus A on the other side. Okay, so you probably saw my mnemonic, but I'm gonna tell you guys anyways. So I was really thinking about it, and I really like locate more, low key. So you can say locate little h2o, and that's gonna be for translocase, ligase, isomerase, lyase, hydrolase, transferase, oxidoreductase. And remember that on this side is 7, on this side is 1, and they're completely in order. You're welcome, because that saves me so much time to have to remember all the EC classifications. Again, if you like these videos, please, please, please follow me here and on YouTube. And thanks again.